Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to material science and engineering. Previously we discussed some basic concepts related to stress, strain and stress-strain relationship through Hooke's law. So in this video we are going to discuss about the different types of elasticity modulus, the constant in Hooke's law, the proportionality constant, which we discussed. There are different types. So we'll discuss Young's modulus of elasticity, okay, which is the modulus of elasticity for length, for longitudinal stress and strain. So just a quick review, that stress is basically the internal reaction force to the externally applied deforming force. When an externally applied force is given to a particular body over a particular surface area, an internal reaction force is generated, and that reaction force acting per unit area is called as stress, and it obeys Newton's third law, action and reaction. To every action there is an equal and opposite reaction. Stress is basically force by area. The applied force is same as the reaction force, so it is basically the reaction force, but as it is equal in magnitude, so it is the same whether you write it this way or that way. Both are the same because they are equal in magnitude, opposite in direction but equal in magnitude. So there are different types of stress: tensile, compressional. These two are basically longitudinal stress, and we are dealing with this, okay, longitudinal stress. Particularly here we'll discuss the tensile stress, okay, which causes elongation. So we have tangential shearing stress and bulk or volume stress. This is bending of materials, this is getting the change in volume of materials, and these two are related to change of length of materials. So tensile or longitudinal stress is that reaction force which is generated per unit area of a body under the application of an external force which pulls a material, okay, from both sides or from one side, which causes it to increase its length, which causes increase in length of the material. The external force causes increase in length of the material, causing it to elongate. And this force acting per unit area, okay, that is called as tensile or longitudinal stress. And the increase in length, the increase in dimension, which is the strain, that is the change in dimension to the original dimension. So here the dimension which we are talking about is length of the material, okay. For longitudinal discussion, the strain which we are talking about is length, okay. Here length is involved for longitudinal strain. For volumetric strain it is volume. For shearing strain it is the bending angle, okay. So here Young's modulus of elasticity is basically change of length to the original length, okay, or the increase in length to the original length, okay. Here this is longitudinal strain. So we have to establish a relationship between longitudinal stress and longitudinal strain, and that is what Young's modulus of elasticity will do. So Hooke's law states that within the elastic limit, the strain produced in the material is directly proportional to the applied stress, okay. Strain is directly proportional to stress, or stress is directly proportional to strain. Sigma is directly proportional to epsilon, and the ratio of these two parameters, that is the constant of proportionality, which is the modulus of elasticity. Now here Young's modulus of elasticity is basically which states that the longitudinal stress is directly proportional to longitudinal strain, okay, within the elastic limit. Here length comes into play, okay. length comes into play. The longitudinal stress is directly proportional to longitudinal strain. So here, for Young's modulus of elasticity, this L part, the change in length part, that is the center of discussion. The longitudinal stress is directly proportional to longitudinal strain. And the ratio of longitudinal stress to longitudinal strain, that gives us Young's modulus. So basically it is a proportionality constant, and it is unique for all materials. For different materials, different Young's modulus parameter is there, and is always specified in the specification sheet when you purchase a material for any purpose. For any purpose, when you purchase a particular material which has specific industry applications, Young's modulus parameter will always be specified. So different materials are used for specific applications according to their Young's modulus. So this ratio of longitudinal stress to longitudinal strain, that is Young's modulus of elasticity. So let's say we have a material, initial length L, then an external force or longitudinal stress causes it to increase in its length. Okay, it causes increase in length of the material. So here the longitudinal stress is force by area, okay, the externally applied force and the cross-sectional area, the ratio of these two, that is the longitudinal stress, and the longitudinal strain is change in length to the original length. So here Young's modulus is basically longitudinal stress divided by longitudinal strain. F by A divided by delta L by L. So it becomes FL by A delta L. F is the external force or the reaction force as they're equal and opposite. L is the original length, A is the cross-sectional area of the material, and delta L is the increase in length of the material in response to the applied longitudinal stress. Okay, so here as you can see, this denominator, it has no units because the numerator delta L is also whatever meter, centimeter, whatever it is, that, and L is also, it has same units. So there is no unit in the denominator, and this is basically Newton force, the unit that is Newton, and area is meter square. So in SI unit, the Young's modulus is basically Newton per meter square, that is the SI unit. And Young's modulus of elasticity, it is unique for every material. It depends on the nature of the material, the chemistry of the material, the chemical composition of the material, and the manner of its deformation. Okay, so here are some Young's modulus values for some materials which are commonly used. Here the Young's modulus is expressed in terms of 10 to the power 9 Newton per meter square. So whatever it is that into 10 to the power 9 Newton per meter square. So for aluminium it is 70 into 10 to the power 9 Newton per meter square, copper it is 110, iron is 190, steel is 200, wood is 13, concrete is 30, polystyrene that is 3. Okay, so here are some values of some commonly used materials with their Young's modulus values. So always remember, there are different types of modulus of elasticity. Okay, the stress-strain relationship has different proportionality constants. Here Young's modulus deals only with length change. Okay, this Young's modulus. Bulk modulus will be for volume, change in volume, increase or decrease in volume. And shear or rigidity modulus, it basically deals with the bending angle. Okay, we'll discuss them in separate videos. So here we have discussed Young's modulus for length, longitudinal stress and longitudinal strain. Okay, longitudinal strain and longitudinal stress. Okay, so here we have discussed about Young's modulus of elasticity. Okay,